Today we're going to practice some more row echelon form, but I did want to do a transition between today's lesson and our next lesson, which is looking at the difference between row echelon form versus reduced row echelon form. So echelon matrices come in two forms: row echelon form, REF, and there's also reduced row echelon form, RREF. Now, row echelon form, which is what we were practicing on yesterday's web assignment, we were looking at using Gaussian elimination using row echelon form. So number one, the first non-zero number in each row reading from left to right has to be a 1. This is called the leading entry. Number two, the leading entry in each row is to the right of the leading entry in the row immediately above it. And number three, all rows consisting entirely of zeros are at the bottom of the matrix. So if we take a look at these three matrices down here at the bottom, you'll notice that you get this triangle of zeros below the leading ones in the leading entries. So notice there's the triangle of zeros here, another one here, and then down here on this last one. Notice again, they all have leading ones and kind of a staircase effect here, leading ones. You have your zero entries at the bottom, so all rows with all zeros go at the bottom. So this is what we call row echelon form. The other thing to also look at is that if you take a look at your leading entries, which are ones, there will be a 0 at the bottom of them for row echelon form. So look at this one. There's a 1, there's 0 at the bottom, 1, 0 at the bottom, 1, 0 at the bottom for all leading entries of 1. Let's take a look now at reduced row echelon form. So for reduced row echelon form, you have to satisfy all of the conditions for what we just talked about, which is row echelon form. But for reduced row echelon form, the leading entry in each row is the only non-zero entry in its column. So what that means, if we take a look at these examples in reduced row echelon form, for this one, we have zeros not only on the bottom of each of the leading entries of 1, but we also have a 0 at the top of the leading entries. So this one, even though it doesn't have a top, we have a 0 at the bottom. This one, leading entry of 1, it has a 0 on top and the bottom. Same thing with this one. We have leading entry 1 with 0 at the bottom, but then this one has 1 and then 0 top and bottom. Here's 1, 0 top and bottom, and I forgot to mention this one. This one has a 1 with a 0 on the top. And then if we take a look at this last one, you have a leading entry of 1, 0 at the bottom, leading entry of 1 with 0 on top and the bottom. So again, that kind of gives a little bit of a hint on whether you're doing row echelon form versus reduced row echelon form. So I want to go back for a moment and show you, like on this one, notice that even though we have a 0 at the bottom of this leading entry of 1, here we do not have a 0 on the top of the leading entry of the second row. We only have a 0 at the bottom. Remember, with reduced row echelon form, there should be zeros on top and bottom of your leading ones. All right, so let's move on. We'll talk more about reduced row echelon form when we start our next lesson. So even if you still have difficulty with that, we'll discuss more as we go. So let's test your understanding. Which of the following matrices is in row echelon form? Matrix A, B, C, D, or none of the above. You can pause the video if you need a little bit more time, or I'm going to wait about 5 seconds and then I will show you the answer. So if you guessed B, that is correct. The correct answer is B, since it satisfies all the requirements for row echelon form. Notice that for letter B, we have a 0 below, a 0 below. We don't need to have the 0 above the leading ones. If you take a look at matrix A, the leading entry in row 1 of matrix A is to the right of the leading entry in row 2, which is inconsistent with the definition of row echelon form. So that doesn't make sense. We have to have the leading entry of 1 this second row should be at the top, and this first row should be the second row. In matrix C, the leading entries in rows 2 and 3 are in the same column. This is not allowed. And in matrix D, the row which has all the zeros, row 2 comes before a row with a non-zero entry. Remember that all 0 entries have to go at the last row. Let's test our understanding with reduced row echelon form. So for this question, which of the following matrices are in reduced row echelon form? Matrix A, B, C, all of the above, or none of the above. So again, I'm going to wait about 5 seconds, give you some time to answer. If you need to pause the video for more time, you can do so now. If not, the answer is D. So the correct answer is D, since each matrix satisfies all the requirements for a reduced row echelon form. So again, for this one, all of them have a 0 on top and bottom. They satisfy all the row echelon form, but then they also satisfy the fact that we have our leading entries not only have a 0 below them, but they also have a 0 above them. So we can see that with all leading entries of 1, 0 above and below, above and below, above, and it's insinuated that there's zeros below. Same thing with letter C. So the correct answer again is D. The first non-zero element in each row is called the leading entry, and they are all 1. Each leading entry is in a column to the right of the leading entry in the previous row. And the rows with all 0 elements, if any, are below the rows having a non-zero element. Lastly, the leading entry in each row is the only non-zero entry in its column. Alrighty, so we are going to practice again using Gaussian elimination. I wanted to do a problem with you where I'm working it out myself. Again, there are multiple ways of doing algebra, so therefore matrices, because it's just using elementary row operations, which is using algebra. Either you're multiplying a row, you can multiply and add or subtract a row from another row. Again, we can pivot, meaning move rows from one row to another. So there are different ways of doing matrices and working them out using Gaussian elimination. So even though you do it your own way, I do it my own way, we should all end up with the same answer. But again, to repeat and remind you how to use Gaussian elimination. Number 1, we got to augment a matrix. Excuse me. Number 2, we have to use row echelon form. And number 3, we use back substitution. In our future lesson, we're going to actually do reduced row echelon form using what we call Gauss-Jordan elimination. But again, for this practice, we're going to do what we did yesterday, just using regular row echelon form and back substitution. So let us look at this first example. We're going to solve the system of linear equations by using Gaussian elimination. So the first thing we want to do is augment the matrix. So let me go ahead and do that. So again, we get rid of all the variables. We just use the coefficients that are important to our matrix, and there is our answer. The second thing we want to do is perform the row echelon form elementary row operations. So that's like the R1 and the R2, or R1 minus R2, and saying what we're doing in each one so that if we do make a mistake, we can go back and see what our operations were, and maybe we calculated something incorrectly. So let's go ahead, and what I decided to do first was I decided to take row 1 and subtract it from row 2 and put it back in row 2. So the first row stays the same, but since I'm subtracting the first row from the second, it's going to change to 0, -3, 5, -6, and then again the third row is going to stay exactly the same. So from here, what I decided to do next was to multiply 3 times row 1, subtract it from row 3, and then put it back in row 3. So I multiplied row 1 with a different color so that, because I'm more of a visual person, to make the subtraction easier. When I did that, I ended up with my third row. I subtracted 3 times row 1, so that's 3 minus 3, that's 0. -3 minus a -1, so that's -3 plus 1. That's how we got -2. 9 minus 5, that's 4. And then 12 minus 14, that's -2. So again, these blue or purple numbers that I put here is basically what I did was I multiplied the 3 to row 1 already because I'm a visual person. I wrote these down even though they're not supposed to be in the matrix. I wrote them down anyways. That way I don't get confused. And then I went ahead and I subtracted those blue numbers to row 3, and then I put it back in row 3. So that's where we are right now. Row 3 changed. It's the only row that changed, and we got 0, -2, 4, -2. All right, so next I'm going to multiply the last row by a fraction of -1/2 so as to make -2 a 1. So the first row is going to stay the same, so is the second row. But the third row, since I multiplied by a -1/2, it changes it to 0, 1, -2, and 1. And again, you're multiplying -1/2 to these numbers here in the last row, and this is what it changes to. Remember, multiplying by -1/2 is the same as dividing by -2. All right. Next, my goal is to get rid of that 1 in the third row. So I'm going to take row 2, add it to 3 times row 3, and put it back in row 3. And so, like before, even though the math is going a little bit faster, because again, I'm not in my element, so I had to pre-record this first to explain it. I'm going to go ahead and explain what I did here. So I multiplied 3 times row 3. That's what these blue numbers are. So 3 times 0 is 0. 3 times 1 is 3. 3 times -2 is -6. 3 times 1 is 3. And then I went ahead and then added row 2. This is row 2 here to those blue numbers, and I ended up with this last row 3. So 0 plus 0 is 0. -3 plus 3 is 0. 5 minus 6 is -1, and -6 plus 3 is -3. So here we have row 3. That's the one that changed. The goal was to make this here, this row, this last row, this 1 into a 0, and that's exactly what we did. So let's go to the next elementary row operation. I decided to take row 3, multiply it by a negative number, and put it back in row 3 so as to make this -1 here into a positive 1. So you'll notice the first row and the second row are exactly the same, but since I divided by a -1 to row 3, then obviously our -1 becomes 1 and our -3 becomes 3. So let's move forward. This is where we ended up last. So I wanted to get rid of now this -3, not get rid of, but turn it into a 1. So I simply multiplied it by -1/3, which is equivalent to dividing by -3. So negative 1/3 times row 2, and I put it back in row 2. So my first row is going to stay the same. If I divide by negative 3 on the second row, we end up with 0, 1, negative 5 over 3, 2, and our last row stays the same. And that's okay. We know that fractions exist. We should know by this point, especially 11th, 12th graders, how to work with fractions. So at this point, we can ask ourselves, is this in row echelon form? So let's take a look. Are the first non-zero number in each row, reading from left to right, a 1? Yes. So we got a 1 in the first row. We got a 1 in the second row to the right of the first row. And then lastly, we have a 1 in the last row to the right of the row above it. So yes, that is our first point of row echelon form. Number 2, the leading entry in each row is to the right of the leading entry in the row immediately above it. Yes, we just said that. We get that effect of this triangular zeros down here at the bottom. So that is also true. Remember, that also means that there is a 0 below the leading entry. So here, first row, there's a 0 below it. Second row, there's a 0 below it. And third row, even though we don't see it, it's insinuated that there is a 0 below it. And lastly, even though we don't see any zeros, a whole row of zeros, it's insinuated that it is there. We just don't write it. So that does qualify as row echelon form. So from here, we are now going to use back substitution. And the way I do that is remember that each of these columns, so that's the vertical, looking at this vertically, each of these columns in this matrix here in this array here at the beginning represents our x, our y, and our z. So I'm going to first put x, y, and z at the top, and I'm going to start using back substitution. So there's x, there's our y column, there's our z column. So I'm going to use row 3. And in row 3, z equals 3. That's already given because we solved for that. Therefore, in row 2, we got the equation y minus 5/3 z equals to 2. Substitute 3 into z, we end up with y minus 5/3 times 3 equals to 2. 3 cancel. We end up with y minus 5 equals 2. Add 5 to both sides. And we end up with 5 plus 2, which is 7. So y equals 7, z equals 3. And lastly, we can go ahead and use these two for our first row. Row 1, we have the equation x minus y plus 3z equals to 4. Substitute the y, we got 7. Substitute the z, we got 3. Combine like terms, we end up with x plus 2 equals 4. Subtract 2 to both sides, and we end up with our solution x equals to 2. Again, using back substitution, we find that x equals 2, y equals 7, and z equals 3. We write this as a ordered pair. In this case, it's an ordered triple because we have 3 values since this is in 3D. We had 2, 7, 3. So for this word problem, or for this problem, we didn't do a word problem. We use Gaussian elimination. In our next lesson, we're going to use Gauss-Jordan elimination, which is going to take this a little bit further, and we're going to more easily be able to see the answers without having to do too much back substitution. But again, we'll explain that in our next lesson. So let's not worry about that here. Now, I'm going to leave some problems because it's hard to do multiple choice with doing Gaussian elimination or row echelon form. So I'm just going to leave some problems on Edpuzzle for you to go ahead and plug in your answers that you got. I am using easy numbers, okay? So, because I want you guys to practice. Again, there is no way for me to kind of see what you're doing in regards to the practice. So, if you are having difficulty and you want me to see your work and take a picture of it and put it onto Google Classroom, like as a message to me, so I can see like what you're doing wrong if you're having trouble getting to your answers. So, maybe I'll put the answers in there too to give you a hint. But again, I want you to practice using the row operations. The whole point is for you to learn how to use Gaussian elimination for future math. Even seniors, you're going to have to take math in college. Some of you, even though you're not taking calculus, might be taking linear algebra because usually that is the math you take next if you're not planning on taking anything that requires too elevated of math classes. So again, try. That's all I'm asking for. Again, if you need help, you can message me through Remind or you can message me through Google Classroom. You can also email me and I will be more than happy to help. Hopefully you are doing fine. Again, have a good day.